Welcome back to another installment on exponents, and let's continue our discussion on multiplying exponents. The problem that we have in front of us is very, very straightforward. All you have to do is to find a common base for both terms on the left and the right. Okay. When you see 125 and 65, the last number is 5. So 5 could potentially be a common base. 5 cubed equals 125 and 5 power 4 is 625. Okay, that means we can replace 125 with 5 cubed raised to the power 2x minus 4. That's equals 5 power 4 raised to the power 7 minus x, right? We can further simplify this as 5 power 3 times 2x minus 4. 5 power 4 times 7 minus x. Because bases are same and we know our logic is a power m equals a power n, then m equals n. Okay, we use that logic. So 3 times 2x minus 4 equals 4 times 7 minus x, which leaves us with 6x minus 12 equals 28 minus 4x. So if you bring the x's to one side, so it'll be 10x equals 40. X equals 4, right? But we're not done yet. It's asking the largest prime factor of x. X can be 4 times 1 will be 4, right? 2 times 2 is 4, right? So we have 3 numbers that are part of 4, 4, 1, 2, right? And 4 is not a prime number. What's the largest of the 2 prime numbers left? It's 2. So the answer is 2. Okay, question is not asking for value of x, it's instead asking for the largest prime number. 4 itself is not a prime number. 1 and 2 are prime numbers, out of which 2 is the largest, so that's the answer, right? Interesting problem. So we have x cubed raised to the power 2 times x power negative 2 is what? This is x cubed. Let's do this portion, which is a power m power n, a power m times n, so x power 6. So we substitute x power 6 in here. So x power 6 times x power negative 2 is x power 4, because this is x a power m times a power n equals a power m plus n. That'll give you that answer. If root x equals y squared equals 16, then which of the following is equal to x cubed times y power 4? Well, first we have to get rid of the square root over x because it's asking for x cubed. Okay, we can't take a square, we can't cube an x root of x. That's just really complicated. Okay, so root x equals y squared equals 6. So how can we get rid of the square root so we have just the value of x? If you take square on both sides, on all sides, so that means square root of x squared, y squared and squared, and 6 is also squared. So that means x equals y power 4 equals 36. How do I know it's y power 4? A power m power n equals a power m times n. Okay, so we know x equals 36. Y power 4 is also equal to 36. So if you cube x, that means it's 36 cubed, right? And y power 4 is also 36, right? So I already know that. So we can write 36 as 6 times 6 cubed, and this is 6 squared, right? So we can write the whole thing as 6 times 6 cubed times 6 squared, right? Because we're substituting this. I know that this particular problem because it wants the value as a numerical value, not just substituting the values in place of x cubed and y power 4. So this is 6 cubed times 6 cubed times 6 squared, right? So a power m times a power n times a power x is a power m plus n plus x, right? So that will be 6 power 3 plus 3 plus 2 is 6 power 3 plus 3 plus 2 is 6 plus 2, 6 power 8. It's an easy problem. as long as the difficult part is getting out of this root of x. Had this been x squared and y power 4, it's a different situation. Okay, it's a completely different situation versus x cubed. You ultimately have to get even if it is, and then it's also the same for x y power 4. The only time you don't have to make any substitution is if it was, say, root x y power 4. Again, I guess you still have to go to x because you're going to be squaring. So no matter what, I think all options lead to the fact that you have to somehow get out of this root x to really be able to solve the problem. All right, this is a very, very interesting problem. You're asked why you're given y power 7 times x power 8 times z squared is less than 0. What they're saying is this whole thing is less than 0. When you say something is less than 0, then each term could be negative, or at least one term could be negative. Typically, when your exponent is a even number, that means even a negative number becomes a positive number. That is, 2 squared is 4. Negative 2 squared is also 4. That's the premise around which this whole problem is asking. If this were to be the case, which one of the following must be true? Yx is less than 0. Yes, y could be negative, or x could be negative, right? If they're both negative, then yx cannot be less than 0 because it has to be greater than 0. Okay, for yx to be less than 0, either this is the possible, this is possible. If x were to be negative, then this whole thing cannot, if x is negative, then y is positive, then this whole thing cannot be less than 0. So this is out of question straight away. Similarly, yz is less than 0. Why? Because if x is negative, it makes no difference. The rest two terms are positive. The whole thing is greater than 0 because negative raised to the power a is positive. So we can't have a number that's less than 0. Similarly, if yz is less than 0, y can be negative or z can be negative. Same logic applies here. Only if y is negative, we can have number negative. If z is negative, that means it's squared, so the whole thing cannot be less than 0. So that fails as well. Xz less than 0, well, this fails right away for the reasons I mentioned earlier. X can be negative or z can be negative because they're both raised to even power. They will never result in a negative number. Considering we're focusing on xz, y is positive. That's by default. So all three options fail. So none of the options are true. So none of the above. It's a very interesting problem where it makes you work, and in the end, the answer is none of the above. So you may feel like your efforts are wasted because you put in a lot of effort, but you ultimately have to answer the question. So from that perspective, your effort is not wasted, even though you may feel that way. And we got two more problems in this video. The second problem, I want to know how much you have paid attention to the previous content we have learned, because there's an easier way to solve that problem. We'll get to it, but before we have a problem in hand is x power 3 over 5 equals 8. Remember I mentioned it to you that when you have a raised to the power m over n, it's same as square root of a to whatever power of n it is and raised to the power of m. Okay, so if you have 16 raised to the power 3/2, that means it's same as square root of 16. I mean, you don't have to write the 2 here because by default square root is 2, but I'm still going to write it for convenience and raised to the power 3. This is 4 cubed, which is 64. I've shown this example before. That's the premise around which this concept is written. So let me go ahead and draw a box here so I don't mix these with this numbers, because there's also a lot of 2s and 4s and 6s and 8s. So we can write this as, which means it's fifth root of x raised to the power cube equals 8 can be written as 2 cubed, right? That what will give you 8. So what it's asking is, what should you substitute for x so that you get 2 as a net result that can be cubed? So what if you substitute, say x is, well, what I'm trying, the clue, the giveaway is the 5, which means 5 and square root goes if it is 25, right? Because 25 is 5 squared, or can be written as, what can be written as? Or I guess what I'm really trying to do is 2 power 5, which would be, what is it, 30, 32, yeah. Well, initially I was thinking of 25, but then 5 squared, if you put 5 squared for x, this won't cancel out. The square root and the 2 won't cancel out, okay? So that won't work. Instead, what it gave me was, I just flipped it. 2 power 5 is 32, okay? If I put 32 inside the square root and put everything back just for time being, what does that give me is, I'm still going to expand the square root as the 32 as 2 power 5, and I have a fifth root raised to the power 3. When you have a 2 power 5, the 5 and the root of 5 cancel out, which leaves you with 2 cubed, which is 8. So essentially, we've got our answer of 8. So that means we have to substitute 32, so x is 32. This is a twisty problem, but not difficult. All right, let's finish this video. So if if a bacteria colony contains 6 organisms and triples every hour, how many organisms are there after 7 hours? There's nothing to convert. There's an easier formula, which is I times R raised to the power n. I is what is it that you have at start. R is what's the rate of transformation, and n is the duration. We went over this in one of the other problems. I is we have 6 organisms to start with. The rate is triples every hour, and the time duration is 7, right? 6 can be written as, I guess, 3 times 2 times 3 power 7. So I guess you can, you can do it. You can actually solve it if it's a calculator section, or I think they might ask you just to do 3 power 1 times 3 power 7 is 2 times 3 power 8. You can just leave it here because I think this is what they wanted. Because we're dealing with exponents, we're not worried so much about the final answer all the time. We're more interested in the actual outcome and how you would combine the exponents together. So if you actually multiply the terms out, which will be a large value, so this will be the answer for the problem. Okay. Consider subscribing to my channel if you haven't already done so. Share the videos, and thank you for watching. I'll see you soon with another video on multiplying exponents.